This video is a very brief introduction to gain bandwidth product. It corresponds to section 18.2.2 of the Applied Analog Electronics textbook. We'll be looking at gain bandwidth product in more detail in later videos. Alright, so what is the basic notion of gain bandwidth product? This is a property of a lot of amplifiers, particularly of op-amps, in that if we look at the gain of the amplifier as a function of frequency, and this is on a log-log plot, as we do all of our Bode plots, what we get is that the gain starts out very high, then it drops, and then often does something even faster at the end. And in this region here, the drop is 1 decade per decade. Now, to specify something like this, there's lots of different ways you could try and do it. You could try and specify what the corner frequency is here and what the gain up here is to indicate where those things intersect, which is what we usually do when we're specifying low-pass filters. The problem with op-amps is that this gain here is extremely high and not necessarily all that well defined. And so trying to specify that corner frequency is a bit tricky. Instead, what the manufacturers do is they talk about what happens where the gain would be 1. So what frequency does that happen at? Because if you notice what's happening here, since this is 1 decade per decade, if you take the gain at any point on here and multiply by the frequency at that point, you get a constant. And that's known as the gain bandwidth product. In this class, because we want to emphasize it as in units of hertz, it's a frequency, I write it as F sub GB. There are a lot of other different abbreviations that are used for it. GBW, GBWP, all kinds of different things. But I like to emphasize that it's specified as a frequency in hertz. One of the op-amps that we use a lot, the MCP 6004, has a 1 megahertz gain bandwidth product, which means that the gain that we get from the op-amp at a megahertz is about 1. At 100 kilohertz, it's about 10. At 10 kilohertz, it's about 100, and so on. Usually, when you're using an op-amp at very low frequencies, up here, the gain is enormous. And so we can use the approximation that it's infinite, which is the way we usually do the simplified analysis of circuits that involve op-amps. Once you start getting up to higher frequencies, that approximation is no longer good, and we have to take into account this limitation of frequency. As a basic rule of thumb, if you've got an amplifier that's producing a gain of G from a circuit that uses op-amps, then you shouldn't be trying to push it past a frequency of this gain bandwidth product divided by G. And like I say, we'll look at this in more detail in a subsequent video.